People will join, sir. Almost 280 have reached. Yes, yes.
Okay.
Yeah, audible.
A very good evening to one and all. ISTEch Talk Series conducted by ISTE MBCET always focuses on versatile, career-oriented topics which are familiar but yet to be explored. The topic which will be discussed in today's talk session is engineering and sailing, and we are very fortunate to have an eminent personality, Captain Ramesh Babu, Indian Navy retired, as our speaker for today's session. I now invite Dr. Babu, faculty advisor at Chapter. Sir, please.
So, Ramesh, sir, I think there is some disturbance from your side. Some background noise is coming from your side.
From my side?
Isn't it Vinayak? Sound?
No, sir. Actually, Ramesh said some background noise is coming up now.
His background noise is coming.
Yes, sir. It's actually very loud now.
It is still coming. Just give me a minute. Just give me a minute.
Yes.
I'll come back. Just give me a minute. Yeah.
Good evening, all. MBCET, Mazagon College of Engineering and Technology, MBCET, which came into existence in 2002, is one of the top-ranked engineering colleges in the state of Kerala and one among 3 engineering colleges from Kerala to be awarded autonomy status by UGC. The MBCET student chapter of Indian Society of Technical Education is indeed honored and privileged to welcome Captain Ramesh Babu to ISTech Talk. The topic of today's session is engineering opportunities in building and sailing warships and submarines. We are all privileged to be here to hear from you, one of the pioneers in the field. Along with this, I take this opportunity to welcome all the dignitaries and students who have joined here, and I'm sure the session will be highly informative to all of you. Once again, I welcome Captain Ramesh Babu to the session, and I hope all of you will benefit from this session. I welcome you, sir, and over to you, Rachna.
Thank you, sir. As I have already mentioned, today's topic, warships and submarines, will be handled by none other than an expert in this field, Captain Ramesh Babu. Sir had retired recently as an executive director with 25 years of experience in Indian Navy, followed by another 15 years at Mazagon Shipbuilders Limited, Mumbai. I'm extremely honored to invite Captain Ramesh Babu to the session. Over to you, sir.
Thank you. Thank you, Rachna. A good evening to all of you. And I'm indeed very honored that ISTE has invited me for this session. And, a special word of thanks to the office bearers of ISTE. I should also thank Captain Sundaram and of the Indian Navy and Mr. Pradeep Mahadikar of Mazagon Dock, who updated me with the latest input for this presentation. And I have to also thank all the participants who are here and those who will be joining in due course. So, without further ado, let us just start. We are a country that sits in the pivot of an entire ocean. We have an entire ocean named after our country, right? The Indian Ocean. So right from times immemorial, we have been in this business of, maritime trade, transport, conquest, and every other, aspect of maritime life, fishing, that needs building of ships and crafts. So right from ancient times, we even got texts like the ISTE and others, which really talk about shipbuilding. It talks about design of ships, and it talks about building of ships. And we have a number of ports and shipbuilding centers which are mentioned in records as early as the Periplus of the Erythraean Sea, which is a navigator's document made in AD 67. So that's the kind of history that we hold, and that tradition continues. Now, in today's scenario, a building of a ship or a submarine is done by a shipyard. Now, how does the shipyard start the business of building a ship or a submarine? The first process is entering into a contract with your customer. And the contract, when I talk, I'll be talking about, different aspects of shipbuilding and sailing of warships and submarines, which would be, and also flagging of activities thereof which are done by engineers, so that you get an idea of what are the engineering opportunities in shipbuilding and operation of ships. So the first activity that normally a shipyard would undertake is to sign a contract with its customer. And since it is going to be a warship or a submarine, in our country, it would be with the Indian Navy. We also build ships for some foreign navies, so we have to sign a contract with them. Now, who in the shipyard are involved in preparing a contract? One of the first persons who gets involved is a planner. Normally a shipyard would have a contract cell which would have a planner. Now, this planner is the man who actually cuts down the entire shipbuilding process into measurable activities. And these measurable activities are then costed by people who are called estimators. And the entire framework is put together by, designers and other engineers who come together, and finally put across to the finance guy. So in this gamut of activities, you see there's a planner, there's an estimator, there are design guys, and there are even production guys who contribute. And finally, it goes to the finance guy. A planner is normally an engineer. Okay, a technical guy. Uh, an estimator is also a technical guy who has a lot of information on market trends and latest costs of items and things like that. We also have a materials man who comes in and who gives us inputs on, okay, what is the cost at which we bought these items the last time? Okay. And he also is often an engineer. When I say an engineer, it's a technical guy who's, now handling materials management in the shipyard. Then there is a designer who often is a naval architect. So all these are the guys who put this contract together, and then it goes to the finance guy. Interestingly, most of the shipyards have engineers who have done later masters in financial management and all, inducted as finance executives. So even there is an opening for the technical guy. Now once this contract is signed, then we get into the design. Actually, the design process starts even while the contract is being prepared. And let's now take the whole ship design. That is designed by the design department in the shipyard. Now, the design department primarily consists of naval architects who are supported by all branches of engineering. For example, there would be mechanical engineers, there would be electrical engineers, there would be electronics guys, there would even be civil engineers, because while designing, you got to decide, okay, where are we going to build the ship? In a dry dock or a slipway? What are the cranes that are going to be used? Which are the other facilities which are going to be used? For example, to build a ship with a very high kind of a draft. The technical word is draft. Basically, the depth of the ship below water. Whether we need to have another dry dock, build a new dry dock. There's a civil engineer comes in. So a gamut of technical people work in the design department. But primarily, it is the naval architect who puts all these things together. So now we have signed a contract with the customer. We have prepared a design. Now that, the design per se is developed in a number of stages. For example, we have a concept design. We have, a detailed design. We have a preliminary design. So all these things are put together and we get the final design of a ship. Now, while designing the ship, there are a number of tests which are conducted. Now, these tests are often conducted. These days, we do it in academic institutions like IITs and all that. But we have, for example, DRDO labs in India, which conduct these tests. Towing tank tests, the behavior of a ship in waves. Sometimes we even simulate those. So these tests are conducted in research labs and academic institutions. They're again, done by engineers. So after all this is done, we are now ready to start constructing the ship. Insofar as the Indian Navy is concerned, a lot of these initial steps are done by the Navy itself. Indian Navy is one of those few navies which has got its own design, branch. We've got a full-fledged design bureau for both surface and submarine, which are manned primarily by naval architects, again supported by a whole lot of other branches. So the Navy makes its own designs also, which could be passed on to the shipyard. So there are now two processes where design takes place. One is in the shipyard itself, second is in the Navy. Both are run by naval architects and technical guys. Okay. So now we've got the design, and when you start constructing the ship, this design is broken down into little bits. For example, if there is an engine room which is to be built, we break it down to the flooring, the walls. We call them the decks, the bulkheads, the frames which are there. So all this detailed design is again done by the design department. Okay, and then they are made into production drawings. And once the production drawings are ready, which, as I said, is done primarily by naval architects, supported by mechanical, electrical, electronics, quality control guys, a whole lot of guys, the production starts. And that activity stems from the planning department. So these detailed designs and production drawings are handed over to the planning department. Okay. While all this is happening, the materials department gets into procurement because there are certain long lead items, for example, the main engine or the missiles which are to be fitted on the ship, or certain specialized equipment. For example, the submarine, there would be a propulsion motor required. There would be rudders and other hydraulic equipment required, periscopes required. These are all long lead items. So the materials department, they start the procurement action in consultation with planning and design. But materials department, almost 100% of material department executives in shipyards are technical guys. Okay, so they are the ones who place the orders, and the planning department starts preparing work orders. They make a plan first. They make a PERT chart or whatever is a planning tool available to decide, okay, what are the important stages in the shipbuilding? What are the milestones to be met? When are we going to meet the milestones? Interestingly, most of the payments, because these are long lead projects, a ship could be, a building of a ship could take anything from 4 to 6 to 10 years. And the cost is very, very high. On an average, today, a destroyer that is built for the Indian Navy could cost us something like 7 to 8,000 crores of rupees. 8,000 crores we are talking about. Okay, so that's, so to get that money from your customer, you want to have measurable milestones. So these milestones are prepared by the planning department, and they make a very nice chart that all the departments have to meet. And that is further split into work orders, which would be handed over to each worker through his departmental officer. Okay. So that is when the planning department hands over the work orders to the production department. Now, in a shipyard, the production department essentially consists of people who deal first with sheet metal. When I say sheet metal, it is thick sheet of steel, specialized material. And they get the steel, preserve it, and then start cutting down profiles from it. Okay. In the submarine, the demand for working on the steel is very, very stringent because the submarine has to perform and the hull has to stay intact at depths of 300 meters below water level. So the precision with which you got to work, the tolerances that you got to meet are very, 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 very high. And the submarine production process is very specialized, but the shipbuilding process is also quite specialized. You cannot have, for example, stress risers left somewhere, which will cause fatigue and cause a catastrophic failure later on. That's not permitted. So very, very highly stringent production procedures are followed. And as I said, the first process, in fact, when we start shipbuilding process, the actual production process, the first milestone, the first production milestone is steel cutting. So the first cut that we take on a steel sheet is almost a ceremonial occasion. Somebody comes and actually flags it off. And that is when one of the payments would be made. Okay. So you start cutting steel. There are CNC machines available for cutting profiles. Then there is rolling done. Then there's bending done. And while doing all this, which is essentially a task of production guys, mechanical guys, industrial guys, people who are very qualified in handling production tools, machine tools. There is a quality control department that is breathing down your neck. Again, manned by engineers. When I use this word engineers, I'm covering everybody. Yeah? So this quality control department is breathing down your neck. Every process will have to be inspected by them. Okay. For example, if you are rolling a sheet of steel, you cannot cross. You cannot break the grain beyond a certain level. You cannot alter the angle beyond a certain level. You cannot have the temperature of the machine going beyond a certain level if it is cold rolling. So these kind of activities are very, very precisely scrutinized by the quality control guy. Okay. And again, tools, the consumables that are required are being supplied by the materials guys who have also earlier procured the steel for you, the steel for you. So all these guys come together, and you will see when production actually happens, sometimes you land up into a bottleneck. For example, an exact drawing that the designer has given you, you may not be able to achieve it. So you go back to the designer, start talking to him. Hey, this design, I really can't, machine cannot really make this kind of a profile. So the designer starts reworking, okay, and he gives you a viable design. So these are a viable drawing. So these are the kind of, joined activities which are done, and the steel is cut into profiles, and then they are joined together. Okay. While doing all this, there is another ceremony that happens, another stage, which is a very traditional stage, which is not exactly followed these days. But if you were to build a ship on timber, like we still have timber shipbuilding in different parts of the country. In Gujarat, it is there. In Calicut, it is there. They start with a keel. A keel is a very, very long and a very sturdy and a very thick beam, which makes the bottommost element of a ship, a bottommost continuous element of a ship. So traditionally, ships were built on a keel. Nowadays, we don't really do that, but symbolically, we also have a keel laying service, which is again another stage of manufacturing. Okay. Now, that is the time when the customer, in this case, the Indian Navy, comes and starts supervising, okay, whether you have done it correctly or not. Incidentally, in all our shipyards, the Navy is continuously present. Wherever shipbuilding is going on for the Indian Navy, whether it is in India, under the public sector, under the Defense Ministry, we have got, Mazagon Dock, which is in Bombay, Garden Creek Shipbuilders and Engineers, which is in Calcutta, Hindustan Shipyard, which is in Vizag, Goa Shipyard, which is in Goa, and under the Ministry of Shipping, we have Cochin Shipyard, which is of course building the largest ship, Vikrant, in Kochi. Under the private sector, there are predominant players like Larsen and Toubro, which is located on the east coast. So all these shipyards where warships are being built or submarines are being built, there would be an overseeing team of the Navy, which is there 24/7. So their office is in your premises. So they are also consistently monitoring what's happening, and along with the quality control department, they are also coming and checking what's happening. Okay. So we now started cutting the steel, we have laid the keel, and in the production shop, the hull of the ship starts taking shape in the form of units, in the form of blocks. These are all parts of the hull under construction. And they have to be eventually assembled somewhere. But while that's happening, the modern trend is to do what is called modular shipbuilding. Okay, where we make this unit into modules and then join them together, like you join the wagons of a train. And there are things that go into these units and blocks. For example, piping. So there would be a piping department. There would be a pipe shop, which would be handling kilometers of pipes. And they would get those pipes, they would pickle them, they would clean them up. Then they would start bending them, then they would start welding them, they would start joining them, they would put flanges on them and give it to the production shop for assembly. Now, those are done by, again, pipe fitters who are supervised by engineers who often done special courses in piping engineering. So these could be mechanical engineers, production guys, industrial guys who come to shipyards and then do some courses in piping. The production guys typically are mechanical, production, industrial, electronics, all branches of engineering, and they come and specialize in their activities. For example, if it is a production, a hull assembly shop, there would be welding required. So these guys would do some courses in welding. Okay. So the hull is now slowly taking shape, and the piping guys have started giving you their pipes. The electrical guys, in the meantime, have gotten with cables. They will come with cables which have got to go into the ship. Okay. some of the foundations of machine are also, installed at this stage. For example, the engines, the air conditioning machinery, the power generation machinery, their foundations start getting installed at this stage. The shafting which propels the ship, the seatings of the bearings which support the shaft, they also start getting assembled at this stage. So a whole host of technical workforce comes in together under these confined spaces and under the supervision and under the guidance of their respective field engineers. They put all this in shape. Okay. So various units and blocks are now got ready. A ship is typically cut into a number of sections, and each section under this concept, the new concept called modular shipbuilding, each section is independently built, and they all get assembled together. The assembly could happen inside a dry dock or on a slipway. A dry dock is nothing but a tank, which is dug into the earth, and seawater is pumped out of it, and it is dry. So you can place your ship there and assemble it together. And when the ship is ready, you flood it up with water and float the ship out. Okay. A slipway is like a rail, which is slanted and slanted landward, and its trailing edge is connected to the sea, but it is slanted upwards, and you start building the ship on it, and at some point you slip it off, and the ship slips into the water. Okay, so these are the two areas on which a ship is assembled. So the assembly now starts taking place. Okay, again, specialized welding is required. Very precise location is required. Okay, the dry dock, the slipways, and all the other civil engineering facilities, even things like jetties and all that, have got to be made ready for the ships to be built and launched. Now, taking care of these capital structures, whether it's a dry dock or a slipway or a jetty, or even underground services that go around all this, is primarily the task of the civil works department. So the shipyard now also has a civil works department, which is a very large department. There are number of civil engineers sitting there who are again supported by electrical, mechanical, piping, and a whole host of other engineers who come together and make these facilities ready for you. Or if they are existing facilities, they get it updated for this new ship. Sometimes they've got to be repaired. There could be sometimes catastrophic failures like a crane suddenly toppling. Now, to avoid that, the civil engineering department has to be on its toes right through. They've got to ensure that the crane is working, and when you want to really lower something or hoist something, it's available on time, because every delay costs you a few crores of rupees. Okay, so the civil engineering department is fairly large, and they, when they have to create new facilities, they start with design. They start with drawing of new facilities. For example, the Mazagon dock is trying to create a shipbuilding facility across on the other side of the bay in Bombay. So our civil engineering department is already making its drawings. The Cochin shipyard is in the large scale expansion. If you pass on the Cochin shipyard side, you will suddenly see, a covered portion under which a huge dry dock is coming. Their civil engineers are very busy at it. They must have, got some drawings prepared a couple of years back, and now they are actually executing them. So civil engineering is a very, very busy department in a shipyard. And as I said, primarily manned by civil engineers, but supported by all other possible branches. Okay. So as the project progresses, you got, the planners on the job, the designers on the job, the production guys on the job, which could be plater shop, which could be assembly shop, which could be welding shop, which could be a rolling mill, which could be even simple things like lathe work, or more complex activities like the electrical guys getting their cabling done, the piping guys getting their piping done. So all these guys are together working. There are hundreds of guys working on this project. Okay. So now the ship is getting assembled on the slipway. And while this is being done, as I said, 24/7, the quality controls are after you. The warship overseeing them, which is again primarily manned by naval officers who are technical guys. They are after you. Okay. And of course, so is your management, which is, it starts from a chairman, then there are directors, there are executive directors. Section 3 and 4 getting assembled. And as I said, is my audio clear? Can somebody, yeah, can somebody just respond if my audio is clear?
So your audio is not clear, sir. It's not audible.
But
It's fine, sir.
how is it now?
It's fine, sir. It's fine now.
Yeah, okay. So as I said, assembling different sections also are milestones. And for the submarine building, these are very, very, very stringent, very stringent. The welding has to be very precise. The welders have to be specially qualified. And, they get into 3G welding and all kinds of precision welding. And most of their processes are highly mechanized also. Okay. So that process is very, very precise. And the outfitting of a submarine, I'll come to that a little later, since it is a very crammed up space and it is very machinery intensive, that's even more challenging. Anyway, the ship sections or the submarine sections are now assembled and it is ready to be launched. Launching is an important stage wherein a VVIP comes, and that is the time when the ship first touches water. It is still a half-constructed ship, but the hull is in shape and it is ready to float out. Okay, so it could be floated out of a slipway or it could be floated out of a dry dock. Both these activities, the launching is done very, very ceremonially. There would be a pujari who would perform a puja, and there would be a VVIP who would break a coconut, and the ship gets named at that stage. Like a ship could be named as Indian Naval Ship Kochi, or Indian Naval Ship Delhi, or Indian Naval Ship Mumbai, Indian Naval Ship Visakhapatnam, or there would be more interesting names like Gomti, or Ganga, or Kaveri. So the naming is done at the launching point, and that's traditionally done by a lady with a whole lot of ceremonies attached. The VVIP who launches it could be the Prime Minister, it could be the Defense Minister. That's the level of VIP we are talking about. Okay, could be the Defense Minister, could be the Chief of the Naval Staff, Chief of the Army Staff, any of those, very, very, very eminent personalities. Their wives often name the ship. Okay, so now the ship feels the water for the first time. The launching is a very precise operation because what you have built on ground has to float safely in water. And that precision operation needs a lot of, balancing of weights, ensuring stability, keeping the ship steady, and ensuring that the ship slips into the water at the right time. When the VIP presses a button, those jacks have to be released and the ship has to really slide down into the water. So to ensure this precision work, again, starting with the designers, planners, the production guys, the quality control guys, the civil engineering guys, they all got to work very, very, very hard for that one day's activity. Okay. So now the ship is touched water, she is pulled and put alongside a jetty. There, she goes through what is called fitting outfit. That is the time when all the major things which are to be fitted inside. By and large, the systems are ready, as I told you. The piping would be ready, the cabling would be ready. But to get that cable activated, you need a switchboard, or to give power to the switchboard, you need a generator. Now, to cool the generator, you need a pump. Or to propel the ship, you need an engine. To connect the engine to the propeller shaft, you need a gearbox. Okay. Now, to keep the ship cool, you need an air conditioning plant. All this gets fitted out. Typically, in a warship, there would be something like 120, 130 pumps alone. Okay, tons and tons of a gas turbine could weigh as much as 15, 20 tons. The gearbox could almost be, 1.5 times that. So this kind of heavy machinery starts getting fitted. So you got a crane to be handled. The materials guys have to get these things right in time for you. So they have got to plan well and keep the item ready. The crane guys will have to, fetch it to the jetty. And as the ship, the project engineers who are often working under what is called a project superintendent and the ship manager. They've got to be ready with their team of engineers and their team of workmen to receive this machinery and put it onto the ship. So the foundation should be ready, the system should be connected well. You have to ensure that once it is lowered and there's heavy rain, it doesn't get drenched. So you've got to have some covers ready. There are certain systems which may come under a machinery, which if you don't do in time, before the machinery is installed, it is almost impossible to do it later. So later you'll have to lift up the whole machinery and do it. So all those things have to be ready, okay? For which you got to, sit and plan for days. Every minute things have to be catalogued and written down and serially, done. So that the ship is ready to receive this heavy equipment and it gets fitted out one by one by one, okay? All the engines, all the motors, all the pumps, all the blowers, all the air conditioning machinery, the switchboard, the power generation machinery, all these things get fitted. So that's a fitting out time. Again, all engineering jobs. Okay. Once it is fitted out, then we normally start at the bottom. So the engines go in first, the pumps go in first, the shafting goes in. The gearbox goes in, the rudders go in, the propellers go in, all these things get in and slowly, those compartments start getting closed one by one by one. And now things have to be fitted out on the top. For example, a galley, typically in a destroyer, there would be something like 350 to 400 people. Even in a submarine, there would be something like 50, 60 people. So their food has to be cooked. Right. So the galley where the cooking takes place will now have to be fitted out, often with electrical stoves and electrical heaters and things like that. The food that they carry, like fruits, vegetables, dairy products, meat, fish, they all got to be kept fresh. For which a refrigeration plant would be ready somewhere lower down, but the cold room to which this is supplying cold air will have to be now fitted out. Okay, so all those things get fitted out, and the ventilation system gets fitted out, and by and large, up to what we call as the weather deck, that's a continuous deck above water, things get fitted out. Then you start working on the upper deck, what we call as the superstructure, which is well above the waterline, where weapon systems, for example, get fitted. Okay. Typically, what happens in the Indian Navy is that we follow what is called a telescopic design. For example, we know that, okay, these are good machineries which are available and which we have been operating for a while, so they're very sturdy. But for the next generation of ships, we need a most modern, weapon system. So we wait. We construct the rest of the ship and wait till we have the best weapon systems available. Okay. So that weapon system comes in when, we have fitted out everything below and towards the final stage of shipbuilding. And they will come and get fitted on the upper deck. Okay. So there would be radars, there would be missile launchers, there would be gun mounting, there would be communication systems, there would be, aviation systems. For example, the flight deck will have to be made ready. All these things will be fitted out towards the end. Okay. By and large, the ship is now ready to sail out to sea. Okay. And that is the time another activity happens. Now, as I said, all the fitting out also will have to be very precisely done. Okay. And in addition to the Navy's overseeing team and the shipyard quality assurance team, and the naval headquarters guys who come and inspect you very, very often. The trial agencies of the Navy get in here now, whether it is for the submarine or for the ship. The trial agency, the Navy has got numerous trial agencies. For example, they have got an agency which tests out weapon systems. They have got an agency which tests out machinery. They have got an independent agency which tests out gas turbines. So all the trial agencies will start coming. They start checking from the installation stage itself. They do some cold checks, whether it's all connected properly, continuity is there and all that. Then they have some simulation checks. Okay, once I start this machinery, will it run fine? After simulation, they go in for, starting and running at low loads and no loads and all that. And finally, they start running the machinery to such an extent that, okay, all of them can run together now and take the ship out to sea. Okay. So when the ship is ready to go to sea, the contractor, which is the shipyard, has to do a number of trials. They are called the contractor sea trials, because right now what we have done is we have proven all these machinery and systems ashore alongside in our jetties, but they all got to work together and perform well at sea. You must be hearing, Vikrant went out to sea for the first time, and whatever was planned has been successful. That is a contractor sea trial that happened. I think recently also one of the final contractor sea trials happened for Vikrant off Kochi. Okay, so that is the time when the ship goes to sea. And this is the time when the Navy starts interfacing with you in a big way. The crew of the ship. Okay, because the other agencies that we talked about till now, the design bureau, the overseeing team, the trial agencies, they are all agencies which have helped you build the ship. But the crew that is to effectively man and run the ship would be doing the training elsewhere. Okay, they would have got trained to commission and run the ship. They will start reporting now. Okay, just before the contractor sees. Now they are the ones who are experienced in taking ships out to sea. So they will help you, the shipyard, as a contractor, to take the ship out to sea so that you can try out all the machinery, all the systems, and prove those in front of the trial engine. Okay. So the contractor sea trials happens in a number of stages. Maybe the first time you go, you just want to see the propulsion system, whether it's running fine. If the maximum design speed of a ship is, let's say, 32 knots, don't go to 32 knots in the first instance. You may just go to 8, 10 knots. Okay, and see, okay, everything is running in fine. We are happy. That's what we do with when you buy a new car also, isn't it? You don't go to top speed straight away. Okay. So that kind of gradual testing is done and sea trials are done. And over 3, 4, 5 sailings, everything gets tuned in and everything gets synchronized. And now the ship is ready to do its weapon trials. Now, there are times when the weapon trials are done before the ship is commissioned and handed over to the Navy, or after the commissioning is done. Okay. Commissioning is a very important ceremony. That is when the ship officially gets handed over to the Navy. Again, the ceremony is done by a very, very important person, as important as the Prime Minister or the President, who is the Supreme Commander of the Indian Armed Forces. Interestingly, there is a stage when the ship has to be named also, So people start asking for names. It's thrown open, okay, we are building this class of ships. We want to name the ship. So you can suggest a name, you can suggest a crest, all that. Sometimes, or very often these days, what we do is that we allow ships to reincarnate. For example, we had a ship called INS Vikrant, which is the first aircraft carrier we had. It took part very successfully in the 1971 war. Okay, so the Vikrant that is being built in Cochin Shipyard now is a reincarnation of the old Vikrant. So, and we borrow everything from them. We borrow the name, we borrow the crest, and everything. Okay, but that is the process that is being by and large done now. But there may be new names which have to be given to the ship. So those we invite these suggestions and invite the logos and mottos and all that, and that gets kind of screened, and finally a number of choices go to the President of India, who is the Supreme Commander of the Indian Armed Forces. He or she will select, okay, this is the name. For example, we have an establishment in the Navy called INS Valsura. Okay, Valsura is an electric eel, and that name was given by none other than Dr. Rajagopalachari, who was the Governor General of India at that time. Okay. So this is a very interesting process. But I just said that by the way. Okay. So the ship has finished all its contractor sea trials, and as I said, sometimes the weapon trials are done as part of the contractor sea trials or later. But now we are at the cusp of a very important ceremony when the ship is to be formally handed over to the Navy. Henceforth, it becomes a property of the Indian Navy, okay, or the submarine becomes a property of the Indian Navy. So that commissioning ceremony is conducted by the Navy. Till now, all the ceremonies are conducted by the shipyard, okay. And as I said, that is the time when a commissioning order given by the President of India as the Supreme Commander of the Indian Armed Forces is read out by the first commanding officer of the ship. He says, I task you to take command of INS Vikrant from this day of this year, okay, and under your command, sail it to meet its purposes. So there's a particular order that is written, okay, and the plaque is unveiled to unveil the name of the ship and the commissioning plaque and everything, and now the ship or the submarine becomes a property of the Indian Navy. But by the time the ship would have started and completed from its contract stage to the commissioning stage within the shipyard from different branches. As I said, design, planning, production, quality control, civil work, all together on the ship itself. There would have been, the footprints or the hand impressions of something like 1,200, 1,300 engineers. Okay. Now, they are the production guys, the frontline guys in the shipyard. They are supported by a whole lot of support departments. Civil engineering is a support department. Okay. Finance is a support department. They are the guys who release the funds. The materials is a support department. But as I said, civil engineering is primarily manned by civil engineers, supported by electrical and mechanical and production and all those other branches. Finance could also have engineers who are later qualified in financial space. Or there could be engineers who have joined the shipyard as engineers and after being in the shipyard for some years, maybe taken an MBA in finance or something like that, they also get, absorbed into the finance department. Okay. Materials, again I said, primarily, practically everybody is an engineer there. Okay, a technical guy. Estimators. It is not only during contract stage that they estimate, they also estimate during the procurement stages, various items which have got to be procured. So they are the ones who give the detailed estimate at that time. You have to negotiate with the chap who is selling you this item, So these guys will give you the estimate. Engineers again. Okay. Now there are other supporting departments. For example, there is an admin department, okay, which gives you all administrative support. Say you want to work in the night, you want to work continuously. So somebody has to provide you security. Somebody has to give you fire protection cover. There are firemen in the shipyard. Then, somebody has to arrange your food. The canteen has to be kept open. Okay. Somebody has to give you water at the right time. So those are the admin functions. They are supported by another department called the technical service department. Who ensure that your electricity doesn't go off, your water supply doesn't go off. Okay. So those are the technical support guys. Then the admin support guys are there. Now there's somebody called the corporate planning department. They are the guys who envision what's going to happen. So for example, you know that you are likely to build a ship of particular size and class 10 years from now. If the corporate planning guys will tell you, okay, 10 years from now, you've got to build these many facilities. Okay. So that corporate planning is an important support department. Okay. They are the guys who also market the shipyard to tell the world that we are capable of producing this. So please give us your orders. Okay. So the corporate planning department is there. Then there are some indirectly supporting departments. For example, the indigenization department. The government now has a thrust on indigenization. So, as many items as possible should be indigenously procured. For which an indigenization department is working in tandem with the industry. to indigenize these items. Okay. The shipyard is committed to channelize a part of its profit towards social function. So there's a corporate social responsibility department. Then there's a medical department, which ensures that everybody is healthy and fine. Okay. The medical department may be purely doctors, but all other departments will be majority engineering guys. Okay. So these are the support departments, and together with the imprint of something like 1200, 1300, 1400 engineers of the shipyard, of the overseeing team, of the Navy's design bureau, of the Navy's trial team, the ship is now handed over to the Indian Navy, and the commissioning crew takes over the ship or the submarine. Okay. So with that, I have finished the shipyard part and the jobs that are available to engineers in the shipyard. Okay. Now I'll come to the Navy proper, but before that, I'll just tell you typically how a shipyard selects its people so that you are aware of that. Okay. The shipyard selects at various stages. Normally a shipyard would have vacancies, or the starting point is a junior engineer, a senior engineer, an assistant manager, a deputy manager, a manager, chief manager, deputy general manager, additional general manager, it goes on like that. Okay. So as young engineers, your opportunities lie in joining either as a senior engineer or a junior engineer or a senior engineer, or as an assistant manager. You could also join as a trainee in a shipyard. Okay. And you just go to the websites of the shipyard. Keep visiting the websites of the shipyard where career opportunities are very, very predominantly announced. And they will give you all the criteria that you require to qualify. But usually what they look for is that you should have had 60% or a first class from a recognized university in the stream that they're asking for. They normally ask for a mechanical stream. Mechanical stream consists of mechanical, production, industrial, all that put together. Then they ask for electrical stream, which consists of electrical machinery, all those engineering streams. Then they ask for electronics, which would consist of electronics and controls and all that. Then they ask for civil, which consists mainly of civil engineering, but there are other specializers available, structural engineering, for example. So they all come under civil. Then they would ask for naval architecture. There are naval architects, which number of colleges and universities are offering, naval architecture courses. Okay, there was a time when even civil engineers were taken in as naval architects, but now with the large number of colleges having naval architecture as a course, that kind of stopped. Okay, so the advertisement will announce what are the specializations they are looking for, and the cutoff is by and large 60%. Okay, so they will tell you this is the qualifying exam, which by and large is BTech. Okay, but nowadays, earlier shipyards were conducting their own entrance examinations after BTech, which was the trend in all the public sector undertakings. But all the public sector undertakings, including the shipyard, have stopped this, and they depend on your GATE score. Okay, so those of you who wish to join a shipyard, it is advisable that after graduation you do GATE. You appear in your GATE exam, which is the entrance exam for doing a PG course. There also the cutoff percentage is 60, but they don't go down all the way to 60. They pick up the guys on top. Okay, so if you do well in your GATE score, typically you are able to score anything more than 80-85%. You are assured of being called for the interview. Okay, so that is when they interview you, and they will select you either as a trainee or a senior engineer or a junior engineer or an assistant manager, depending on what is the vacancy available. Okay, pay scales are good, perks are good, and it is a stable, steady job. Okay. Another thing I wanted to tell you is about campus placements done by the shipyards. Shipyards also visit campuses. They announce, but by and large it is done for naval architects. Okay, because there are few colleges which have been supplying very good naval architects like QuiSat for one. IITs have naval architecture course. So these institutions we go and do campus placements also. Okay, so this is the way to get into a shipyard. Even after you are already employed, as an engineer somewhere, you want to get into a shipyard, you can get in at a higher level as a deputy manager or a manager or a chief manager, or even at higher level. We have people coming in, even a director, who may have worked in another industry and they come in here as director. Okay, so at every level, there are opportunities available for you to join the shipyard. Primarily, keep looking at their website and their advertisement. Okay, so that is as far as the shipyards are concerned. Now we come to the Navy proper. Now, how does the Navy run a ship? The Navy's officer cadre, okay, is the one that leads the men to run the ships, okay. And the officer cadre is essentially divided into executive, engineering, or technical, okay, executive, technical, aviation, submarine, okay. Or the primary division is, executive and technical. But there are other supporting branches. For example, there's a medical branch, there's an education branch, there's a logistics branch. Okay, but primarily it is executive and technical. These are the guys who run the ship. Okay, within the executive branch, there is, there are specializations. One is called navigation and direction. These are the guys who actually navigate the ship. They take the ship from place A to place B. Okay. Then they are also the guys who direct aircraft. We have aircrafts in our Navy. So the direction of the aircraft are also done by the navigation direction guys. Okay. Then we have the gunnery and the missile guys. They are the guys who actually fire the weapons. Okay. The gunnery and the missile guys. Then we have the communication and the electronic warfare guys. They are the guys who man your signals and who get messages from all across. They are the guys who interpret the intelligence that is available. They are the guys who monitor the electronic scenario and decide on, okay, this is a potential threat. And then they tell the navigator, okay, you have got to go from place A to place B. And the missile and gunnery guys that you've got to fire your guns at so and so time. So the electronic and communication electronic warfare guys. And also the anti-submarine warfare guys. They are the guys who fire weapons that go underwater. Okay. So there are 4 specializations: navigation direction, communication and electronic warfare, gunnery and missiles, and anti-submarine warfare. Now these consist primarily of the executive branch of the Navy. Now, as on date, the intake for the executive branch is through the National Defence Academy or the Naval Academy. Okay. So if there is any young engineer who is listening to me today, who is, let's say, in the first or the second semester and who is not yet touched the age of 19, he or she can apply to join the NDA. This particular course onwards, NDA has opened its doors for girls. It's a phenomenal decision that they have taken. And I think the first batch will have 19 or 20 girls. Okay. So that window is also opening. The Naval Academy has not yet started opening its doors for girl cadets. Okay. But people who are in the first year or even in the second year, if you are less than 19 years old, you could apply to join the National Defence Academy or the Naval Academy and join the executive branch. Primarily, all the officers of today's Indian Navy, okay, are engineers. So if you join the Naval Academy or the National Defence Academy, you will graduate as an engineer and join any of these branches. Okay. You could also join the technical branches after joining the National Defence Academy or the Naval Academy. Like, I am a product of the National Defence Academy. But I joined the Navy, and then the Navy offered me an engineering course, which I passed, and then they sent me to the IIT Bombay to do a production engineering course. So even if you join the Navy as a cadet, there's a window available for you to specialize in the branch of engineering at a later date. Okay. So you can join the MBA or the Naval Academy and join any of these executive branches. Now we come to the technical branches of the Navy. That's where your opportunity lies in a big way. Okay. The technical branches essentially consist of the marine engineers, who are the mechanical guys, or the industrial guys, or the instrumentation engineering guys. When I say the marine engineers of today's Indian Navy, they are not just running engines. They're also looking at the controls. They're also looking at the electronics attached to this machinery. And okay, so you could even be an instrumentation engineer. I had a friend who was an instrumentation engineer who did extremely well as a marine engineer. Okay, so any of you who's doing engineering in any of these fields could join the Navy as an engineer. Okay, then we have as a mechanical or a marine engineer. Then we have an electrical branch. Okay, which takes in people with electrical, electronics, and all that. So the machinery guys, the mechanical or marine engineers are the guys who run the machinery and systems, and the electrical guys are the guys who ensure that power supply is available, the weapon system power supply is very precise, power supply is available there. Things like frequency fluctuations and all can affect weapon firing, or electromagnetic interferences can affect weapon firing. So they want to ensure that precise supply, voltage, current, frequencies, and everything is available. So that's the electrical branch. Okay. So together, these guys ensure that the ship is moving and it is ready to fight, and the actual movement is done by, as I said, the navigation direction guys, and the fighting is done by the weapons guys. Okay, the gunnery guys. So the engineers actually run the ship, and that is an opportunity for you. The electrical engineers supply electricity to all the systems and machinery. That's also an opportunity for you. And how do you join there? The opening available to you as engineering students is to join the Navy as what they call as a short service engineer. Okay. Earlier, we used to even go and do campus placement and pick up, students based on their 7th semester marks and engage them and start paying them in their 8th semester and engage them on a permanent commission, which meant that you have to serve for at least 20 years. But nowadays, we take, engineers, both mechanical and electrical. When I say mechanical, it kind of covers everything else. And when I say electrical, it covers electronics, controls, and everything else. So we take them in as short service officers. Okay. The Navy had designed an entrance test, but that has been put on hold thanks to COVID. So even today, when you join as a short service officer, it is your one of your semester marks, either the 6th or the 7th semester mark, and your consolidated performance before that. That is taken into account. Okay, so that's an opening for you. Then we have the naval architects who are designing ships. To design ships, they not only sit in offices and design ships, they also come and work on board ships. Okay, those are naval architects. And the Navy announces vacancies for naval architects, and people who are qualified as naval architects can join these. Naval architects, even now, they take them in as permanent commission, which means you have to serve for 20 years. Whereas the short service engineers, the technical guys, have to serve first for 10 years. You can sign on for another 2 years, and maybe 2 more years after that. So 14 years altogether you can serve and reach, ranks up to the commander rank. Okay. After that, when you leave, if you join in the first shift, then you are only 20 years old or 21 years old when you join. So when you are leaving, you are either 34 or 35. Okay. So you are a well-trained, well-qualified all-rounder who is available to pick up a job in the market. So you can, join the industry at a higher level after getting all the experience free of cost and a good quality of life in the Navy. Okay. So those are vacancies available. And now the ship is also supported by a whole lot of other branches. For example, I told you about the logistics. They're the ones who ensure that the ship gets fuel in time, the ship gets water in time, the ship gets food in time, the ship gets rations in time, the ship gets its paint in time. All these things are ensured by the logistics, all the materials are available. Now, there, if you're done, the Navy announces these vacancies. Okay. And logistics is a branch where they take in ladies also. So if you're an engineer and the Navy will announce for logistics branch where they take in engineers, a lady engineer can go and join them. We have a number of lady engineers who have become logisticians in the Navy. Okay. Another branch is the aviation branch. And interestingly, girls do join, engineers do join the Navy as pilots who are flying aircraft. Okay. So that's a very challenging opportunity, a very interesting opportunity available to both boys and girls who are engineers to join the Navy as pilots. Okay. A lot of our aircraft are flown by ladies, and as somebody who has flown, who has been a passenger in enough of these military aircraft, I can tell you we feel safer when ladies are flying aircraft. Okay, I have flown, in the Himalayas with men and women pilots. I always felt safer with, with the delicate controls that's done by women pilots. Okay, so I'm sure people in the Navy would be preferring lady pilots. Okay, so that's a big window available to you. In the aircraft, we also have what's called the observers. Who are in the larger aircraft, they are looking at the radars and all that. A larger aircraft is manned by a number of people, and observers are one set of people who support, the pilot in giving him all information. So ladies and gents, both engineers, are taken in as observers also. Okay. Then we have air traffic controllers, who are also by and large engineers. Okay. Then we have the education branch, which primarily looks at people who are inspectors, who are professors, who are teaching in the Naval Academy, the Defense Academy, the Navy's other education institutions. Interestingly, Navy is a service which keeps giving you a number of courses. As you go, like I did my MTech as a naval officer. Okay, I did my MPhil as a naval officer. There are people who do doctorates as naval officers. So the Navy keeps offering you these kind of courses. So they keep updating you on information. And these trainings are conducted by the education branch. Engineers have opportunities there also. Okay. They're also looking for, like, there would be billets for historians, like somebody who has done an MA in history or an MA in English. They could also join. But technical officers also do have vacancies available in the education branch to teach in the Navy. Like, we have the Naval Academy and the NDA, which is now teaching engineering. They qualify people as engineers. So there would be engineers required. There would be MTech holders required to teach these cadets. Okay. So that's also a billet available to you. Then there are, other branches, for example, law, where of course they take in only lawyers. Okay. Then we have some more specialized hydrography, for example. The hydrography is a branch where there would be openings again for engineers. Okay. Then within these branches, there are other specializations you do. For example, you could be in the surface Navy, which essentially means the ship, or you could be in a submarine. Okay. So you get an opportunity to sail underwater. And all these branches are available in the submarine also. Okay. Then you could become a commando. There are commando operations, clandestine operations which get done, where the most physically fit guys, who can undertake all these challenges, by and large in very, very dangerous situations, they become marine commandos. And that's a very niche specialization that we have. And there are opportunities there. Okay. Now, the Navy is not just about running ships. Okay. While you may do a 14-year tenure in the Navy, your tenure on board ships could be something like 7 or 8 years. The other years, sometimes you would be doing some training, you would be upgrading yourself, but there are billets available for you ashore. So the Navy's job is a combination of both shore jobs and jobs afloat. Okay. So shore jobs for an engineer typically consists of, as I said, teaching is one. The Navy has different training establishments. Large training establishments, some of them are better equipped than IITs and all. Okay, with most modern teaching aids and technologies available there. So you could become an inspector there, or you could man a ship repair yard or a dockyard. These ships, to keep them running perfectly, they've got to be maintained very, very regularly. Okay, and they've got to be repaired. And that's a very challenging job that you've got to do as an engineer, to run a dockyard. Okay, ships come with all kinds of defects, so you've got to ensure that you repair these ships, or you maintain them and make them fit to go to sea again. So that is an appointment or an engagement, which is a very good engagement for an engineer. That's to work in the dockyard or the ship repair yard, where you get very, 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 very proficient in in opening up the machinery and seeing the internal process. In a ship, you are essentially running it, you know. So that's a different ball game. But here you are getting deep into the machinery, okay, and opening it. It's almost like a surgeon, okay. So you get hands-on experience in actually repairing and maintaining machinery, which is also very good. It prepares you very well for a job outside, okay. So dockyard is one. You could also get into. We also have aircraft repair yard. Okay, so those of you who get in as air engineers. By the way, I did not tell you about air engineering. You know, people who are doing aviation engineering, they could get into the Navy as air engineers. So we have aircraft repair yard. So like ship repair yard, there are aircraft repair yard. Okay. Then there are opportunities available for you to repair submarines. Okay, so all these opportunities available, and now those opportunities combined with the sailing opportunities make you a complete engineer. You know, a complete engineer. While doing all this, you are managing hundreds of men. So it makes you a perfect manager. Interestingly, military, along with politics and religion, is an entity which does not have professional HR management, and it's a very good thing, because here you got to lead from the front. You cannot throw a rule book and tell him, yeah, this is the conduct rules you got to perform. No. Sorry, these are very big challenges where you got to lead men into sometimes even risking their life. So their leadership counts, and I can tell you the best, HR managers are leaders. Okay, so if you become a leader of men, and also a professional manager of systems and a maintainer of systems, then you become a complete package as an entity or a resource available to the industry to take you in after a tenure in the Navy. So you often have a second inning. Okay, so that is the beauty of being a naval officer as an engineer. And another option available to you, as I told you, is to be in a shipyard. Okay. So these are the broad avenues available to you as young budding engineers in both ship building and operation of ships or submarines. Okay. So with that, I conclude here. So now you can ask me anything that you want to.
Hello, sir. Deepak here.
Yeah.
Sir, I have a doubt regarding the where the ship is built. You are told that we either go for dry dock or slip, right? So, what is
Yeah.
the criteria of selecting one? Is it the weight of the ship or the cost? What is the criteria? Which one we should go for the particular ship while building?
Yeah. Okay. Okay. I'll just give you a broad outline of what is the Indian Navy's role, or primarily any Navy's role. The Navy's roles are multiple. One is, of course, to be a maritime strategy platform, to be a fighting platform. Okay, so that is one role. The second role is a diplomatic role, where a warship or a submarine is a sovereign territory of that country wherever it goes. So, for example, if you are in a warship of Indian Navy, and let's say you go to you go to Sydney, that particular warship is Indian territory in Sydney Harbour. Okay, because you are flying the Indian flag. So that is a diplomatic mission where you are going and telling the world that I am here. Okay, and you also join hands with a lot of navies. One typical case is the piracy that goes on in Somalia and other regions. We are operating with other navies like the French Navy and the British Navy and the US Navy to keep this pirates at bay. So that's a diplomatic role that you play. So there's a military role, there's a diplomatic role, then there is a policing role. When the country or the Navy is called for some action within the within our territorial waters. By and large, now that is done by the Coast Guard. Whatever I told you about the Navy is applicable to the Coast Guard also. So you youngsters have an opportunity in the Coast Guard, which is as good as the Navy. Okay. So in the territorial waters, the Coast Guard which does it now, but earlier the Navy was also doing it. And we also have a humanitarian group. You heard of how the Navy does relief operations. We carried liquid oxygen when we were hit by a crisis in shortage of liquid oxygen, or we go and help other countries. We once in Maldives we actually avoided a coup in Maldives. So these kind of humanitarian operations also we do. So there are several roles that the Navy does. Okay, and to do all these roles, the Navy needs different types of ships. It could be a large aircraft carrier, it could be a small patrol craft. So ranging from a small patrol craft to a large aircraft, where patrol craft could be displacing something like 200 tons or 150 tons, whereas an aircraft carrier could be displacing something like 80, 90,000 tons. Okay. So this range of ships is what is required, and a country like India, which juts into the Indian Ocean, and it is also a growing power, we need practically all kinds of ships. So it cannot be governed by one criteria. So what the Navy does, this is available in public domain. The Navy does what is called a perspective planning, where they decide, okay, for the next 30 years, this is the threat criteria that we are going to face. Okay. And to face that threat criteria, today we need to build this ship. Or they say, okay, for the next 60 years, this is the threat criteria that we are facing. Okay, so and so would be our primary adversary. We are likely to have this kind of a threat, that kind of a threat. Okay, for which we need this type of ship. For example, they might say, okay, we need a nuclear submarine, or we need an aircraft carrier, or we need only petrol vessels. So they decide on the type of ships that we require based on the threat that is expected in the future. Okay, it's a beautiful game of planning. Okay. And based on that, they decide, okay, the Navy will prepare a wish list. I want a Navy. Like today, the Navy says, I want to be a Navy with 150 ships. Okay. Then the government looks at it and says, okay, friend, to make you 150 ships, I have to give this much of the GDP to you. But sorry, my poverty level is bad, or I need to produce more food. Or I need to educate more people, or I need to pump in more money to help. So sorry, I may not be able to give you this ship, but you can look for something else. So that is a balancing act between the Navy and the government, depending on the Navy's plan and the availability of funds. Okay, so that's how this is done. Okay, and so the type of ship selected is done on a combination of factors, Deepak. It is not just cost of factors. Okay. So it's a number of factors that come into play. But the final thing is the availability of money. So that's how it is.
Okay, so thank you.
Yeah.
Good evening, sir. Vinayak here.
Yeah.
So my question is, we are actually in a technological era. Like we're moving towards a more and more technologically advanced fields. So I think you have heard about Web 3.0, metaverse, and all. We can actually virtually construct anything we wanted in a metaverse, and with the use of an VR system, we can actually go through them. So this kind of technology, where you can virtually construct an entire, maybe a ship, a submarine, and go and checking its functionalities. How does this kind of technology will change the future of shipbuilding as well as sailing? So your sound is not audible. So you're not audible, sir. So we're not audible, sir.
Sir, it's muted. It's muted. Your audio is muted.
Sir, not audible, sir. Sir, audible, not audible, sir. Sir, you're actually muted, sir. You're actually muted.
Yeah, yeah. Okay.
Yes, sir.
Yeah, sorry. Okay. So what I was saying is that virtual reality is now a tool that is very effectively used in shipbuilding. We've got this VR lab where we actually project the design and finalize the design using VR technology, and we also have walkthrough models. We walk through the ship and identify, okay, where is the blockage, where an equipment needs to be shifted, and all that. And then the VR models are cut into sections and brought onto the design table. And from there, on the design table, like if you go and see, the desktop of a designer in a shipyard now, it's virtually, a good, most advanced 3D platform, that desktop, and there they actually play around with this and then make the detailed designing. And we have ship design softwares available which can actually take this design from the design office and give it to the cutting machine without any human interference in between. And the cutting machine will follow, the design which has been picked up from a VR model. So that much of advancement is there. That answers your question, Vinay?
Yes, sir. Thank you, sir. Thank you, sir.
Yeah.
Good evening, sir.
Yeah, good evening.
Sir, I am Rayan, and I had a small query. So since
Yeah.
I am a computer science student, so I had doubts of what are the scope of computer science within Indian Navy. As you mentioned earlier, there is VR technology already in place. So what are the other options available for me as a computer science student?
Yeah. I'll cover both shipyards and the Navy. In the shipyard, for example, in Mazagon Dock, out of I think we have something like 1,200 officers there. Out of the 1,200 officers, we have an IT department. We have an independent IT department which is manned by something like 40, 50 officers. So, almost 5% of the officer strength is manning this IT department. We have. I said that we run some advanced design software. Not only that, we are on an ERP platform. So that is to be managed by this computer science, guys, computer engineers. So we have a large number of computer engineers, and we have both in the shipbuilding division and the submarine division of the shipyard, we have independent IT departments, okay, which are not only looking after basic IT things like databases and all that, but they're also managing this ERP system, okay. So they are there. That's as far as the shipyard is concerned. A lot of other, branches of the shipyard. For example, even in the civil engineering department, there would be an IT guy, because he would be the IT administrator there, because they also work on a network. So there they will have their own server, they will have their own firewall and things like that. So there would be an administrator there also. So we have a dedicated IT department plus IT guys posted in almost every department. Okay, that is one. That's as far as the shipyards are concerned. As far as the Navy is concerned, IT, they almost treat it these days like a brand. Though I did not specifically mention it, but the Navy comes out with specific announcements for computer engineers. Very specific announcement that we need only computer engineers. So there are opportunities available. What I suggest to all of you is that you join the Indian Navy website and register yourself there, and give your qualifications and everything, and keep updating your qualifications. So whenever there is an opportunity available, it will send you a mail. The system sends you a mail saying that, okay, The Navy is now looking for computer engineers with this qualification. So if you qualify, you can actually go and apply for it. Registering in this system does not mean that you're going to go for, the SSB. SSB, the Services Selection Board is the selection process to join the defense forces. I did not discuss much about it because right now we don't really need to know about it. So what I suggest is all of you go and register yourself in the Join the Indian Navy website. Give your qualifications, keep updating those. Like today, if you're saying you have the fourth semester, and once you clear your, fifth semester, you say I'm a fifth semester guy. They will keep, informing you that okay, this vacancy is available. So Revan, the IT is got enough opening in the Navy and in the shipyard. Okay.
Thank you, sir.
Yeah.
Are there any more questions? No?
Anything that anybody has typed in or something?
Uh, so I think actually we have answered all these questions and asked. We actually combined most of the questions and asked.
Okay. Yeah.
Okay. So I think this brings us to the end of the session. Ramesh sir, hats off to you. This session without the aid of a PPT to speak for around 1 hour 15 minutes
Yeah, I
continuously.
normally believe I have PPT slides and my Ranjit and Pradeep and all, but normally I believe one got fed up using this PPT. So I now believe that PPTs are used by a guy who does not have the power to make his presentation. If you have the power to make a presentation, you don't need a PPT.
Yeah, I do agree with you, sir. This was a wonderful session, and the thing is, nothing trumps experience. This presentation is an example of someone who needs to. I mean, it's a testimony to that statement. Nothing comes experience. Your experience in the area and the wide exposure that you received during your uh, during your service was evident in the presentation, and we are very much privileged that we could hear such your talk. And around 100 people were there throughout the session, which at this time, which is also a testimony to how interesting the lecture was. So I will now, I would personally like to thank from my behalf and the students of Marvestelius College and all the participants who are listening. And now I would like to give Krista the opportunity to convey the vote of thanks, and after that we shall wind up the session. Thank you.
Yeah, Deepak, where is Marvestelius actually?
So Marvestelius is in exact location is Nalanjara, Trivandrum.
Okay. Oh, I know. You are coexisting with that other college, no? The old college.
Yes, sir. Marivenis College.
Marivenis. Yeah, Marivenis. Yeah, I know.
Yes.
Yeah. So, see, in case you all need some presentations on man management and or communication and all that, we can do all that. That's not a problem.
Yeah, sure, sir. We will contact you. And if you are ever come from to Trivandrum, it would be our privilege if you are able to visit our campus.
Yeah. I keep coming because I am from science school, so I keep coming to science school anyway. So.
Yeah, I actually reside in Karakotam. I stay in Karakotam.
Oh, that's nice. Okay. Yeah.
Krista, over to you.
Good evening, everyone. Engineering is a vast field with various opportunities, with more and more opportunities increasing as the need goes up. It is very important to keep yourself updated on these various fields. This is where the today's session's importance come. I wholeheartedly thank Captain Ramesh Babu, retired recently as Executive Director with 25 years in the Indian Navy, followed by 15 years at Mazagon Shipbuilders Limited. Thank you, sir, for making time for us amidst your busy schedule and clearing our doubts. Your session was enlightening and informative, and your exposure and experience speaks volume. I also thank ISTE MBCET for recognizing the students' needs and for giving us this opportunity. I would also like to thank the faculty and student coordinators and all our distinguished guests who have accepted our invite and kept their time aside for us. Last but not the least, I would like to thank all the participants who have joined the event. Thank you for making this session colorful.
Yeah, thank you, Christy, and all of you. But I always tend to differ with this one busy schedule thing that all of you say. I don't think anybody is actually that busy. It's how you manage your time. One is never busy. I think that's a misnomer. We don't plan and do our jobs in time. That's why we get busy. So I'm not busy. I'm sure if you manage your time well, nobody will be busy. Okay. Thank you.
Okay, thank you, sir. Thank you.
Yeah,
So we shall
thank
see
you.
many more sessions.
Yeah, thank you. Yeah, thank you very much.
Thank you, sir.
Thank you, sir.
Yeah. Thank you, Sri Kumar. I think thanks.
Thank you, sir.
I got Tina is telling thanks. Okay, thank you.